Hey everyone, welcome back to the shop. We have a small part here that we need to machine. Does anyone recognize what this is or what it's for, or maybe even how it's used? Well, in case you didn't guess it right, this is for a bass guitar. And there's the problem. It's broken. And I'm told that this is an obsolete part that you can't source anymore. They can't find one. And so they came to me and asked me, could I make one of these? And I said, yes, I think this is something that we can do. And as soon as I looked at this, I instantly thought of my Milltronics Tool Room Mill. This is a perfect job for a tool room mill. And that's my plan. That's what we're going to be on today. Hopefully getting this part made. So this particular piece, the factory piece, looks like a die casting made out of pot metal, I'm sure, kind of like aluminum. Not really sure, but it is a die casting. And they asked me if I would make this out of steel. When I said that, is there going to be an issue going from basically some type of aluminum, pot metal alloy to a steel? Is that going to be an issue? And they say no. I was concerned maybe the weight of it, could have an effect on it. And they said no, it actually should help balance it out a little bit more. So in fact, this particular piece, this is called an adjustable bass bridge saddle block. Now, I don't know anything about musical instruments other than how to play the tuba. And I really, really love the sound of musical instruments, especially the guitar, the electrical guitar, the acoustic guitar. I really appreciate and respect the music industry and all musicians out there that can make music. That's one of the things that I absolutely love is music, and I enjoy listening to it. So I thought this was a really cool opportunity to help someone local machine a component that they need for a guitar. This one going to be for a bass guitar. And he says this is for a 1990 Ibanez Sabre bass. I apologize if I said that name wrong because I can't remember how he pronounced it, but Ibanez Sabre bass. All right, so we need some material for it. So I ordered some 303 stainless steel from McMaster, and in fact I ordered a total of 1 foot of that. With it cut, we have one extra piece right there. So we actually have enough to create 3 parts there. Now they only want one, and that's what they're buying is one. But as you guys have probably seen in some of my previous videos, that sometimes making just one part on the CNC, it isn't all that fulfilling. It's nice once you have the part set up and you have it proven to be able to go ahead and stick another piece of material in there and watch it do its thing and cut another part. So I got a total of 3 pieces there that we can use to machine 3, and that's my plan. Go ahead and get 3 of them machined. So I've already taken the time to model this in Fusion, and I had some help from my buddy Kevin, Mechanical Advantage. He helped me ensure every time that I have to model a part, there's always things that I get hung up on and not really exactly sure the proper steps to take. So we get on a session and we go through, and he ensures that I model it correctly and choose the correct tool paths to be able to machine this as well. So thank you, Kevin, for your help with that. Hopefully it's going to work out pretty well. I'm ready to get over to the tool room mill and start getting my tools set up. So I wanted to go ahead and get this intro done and show the part that we've got to make right here, and go ahead and start getting our tools set up. So this is going to be a 2-op setup, and Kevin suggested that when we start, we actually start and finish the bottom first. So we'll take our stock, set it up in a vise. We're just going to use a face mill to clean the top off, and we use a 1/2-inch end mill to cut this outside area finished. And then once that is done, then we can flip it over and we'll set it back into another vise with some soft jaws for op 2, and this will be finished on the outside. We'll be able to clamp it and come in here and do all of the milling needed to cut all these notches out. So there's going to be quite a few tools involved with this. For me personally, what I've what I've chosen to do with the different tool paths that we're going to make, I've got 10 separate tools that we're going to be using. So we'll go over there and get these set up, and I'm actually excited to see this part being made. So let's go get started on it. Our machine of choice today is going to be our Milltronics Tool Room Mill. This is going to be the perfect machine to get this part made on. I've already gone through and got all of my tooling figured out that I'm going to be using. We're going to have a total of 10 tools to make this part. It's kind of hard to imagine that, well, why does it take 10 tools to make that part? But on the CNC, I don't know, that's just how it goes. You've got all these different features that you've got to, do in there. We need to face it, we need to mill the perimeter, we've got holes to drill and tap, we've got these little narrow channels in here that's 80 thousandths wide that you have to mill. I've got an angle on here on 3 of these features here that, 3D surfacing. So it just takes quite a few tools. Nothing wrong with that at all. And that's another reason why I love now having 2 CNC mills, because this guy is going to handle a lot of our job shop work and things like this, where we only have, one small job to do. And we can take our tools out of the umbrella here, keep them stored in our cabinet, and then whenever we set up for a job, we can, install these tools and run them for the job. All right, so I'm getting ready to get these in there. I got to touch them all off. Here's our 2 work off sets. This is going to be for op 1 here. We're going to use our Talon grip jaws to be able to take our stock and hold it like so to do the top and mill the perimeter. And then what we'll do is take it out from here. I've already got these soft jaws milled. I actually milled those in our KBC mill. Got a little reel of that. I'll show you if you're interested. So we got those milled and got them set up in the vise here. And I still need to touch off our work locations too, by the way. But we'll put our stock right here in our soft jaws. We've got a stop set up, and we'll use this vise here to finish out op 2, or the top side of our part. So that's the plan anyway. So I'm gonna get started getting all of our tools installed now. So what's been helpful for me whenever I have to install tools for a program over here on the mill is once I get my program written, do the CAD and the CAM on Fusion, I go through all the ops I got to do, in this case op 1 and op 2, and I write down each tool that I have to use in order, whatever that tool is that I'm going to use. So I just make a list and I write down what that tool is, and then I come back and I put whatever corresponding tool number it's going to be. For our tool room mill, this goes with, we can hold 16 tools, and with it being the umbrella style, each pocket is the tool number. It's a different case over there on the side mount tool change on the VM. You don't go off pocket number over there, you just go off tool number. But anyway, we've got our list right here, so I'm just going to start with tool 1 and work our way down to tool number 10. So let's see if I can remember how to do this. I believe you go to Run Program and then Tool Set. Hit cycle start to start this. I have a tool out of the spindle there. Tool number set to offset, And we're gonna go with tool number 1 that's already in there because we actually have tool 1 called up already. I took it out of the machine. And we're gonna hit enter, and it's gonna ask you, do you want length or do you want length in diameter? I usually just go with length. In cases where it really matters, I'll do the diameter where it'll touch the tool on the side of the tool setter to measure the diameter of the cutter. Usually pretty important with end mills that you're using to cut features and slots. We're not really worried about that today for the part that we're cutting. So we're gonna go with length, and then it asks you for the tool number, or tool diameter, I mean. In our case, this is gonna be a 2-inch face mill. So we're just gonna simply enter 2, enter, and then it's gonna ask you, all right, so it's jogging over to the center position of the tool setter, and now is where I actually install the tool and jog it down or hand wheel it down as it needs. All right, tool number 1, this is a 2-inch Tungaloy face mill that we're gonna be using. A really cool face mill. This is the Quad, the square inserts that give you a total of 8 cutting edges, and then we have 5 cutting edges on here to use. Always clean the taper shank off. All right, that's installed. So it asks you to hand wheel it down. We want Z. I'm gonna use this guy right over here and just jog it on down here so we can touch it off. All right, and since this is such a large cutter, 2-inch, we need to move it in Y. I'm gonna bring it over and just line up about in the center, one of those inserts. I'm gonna bring it down a little bit closer using our Z movement. Pretty close, just like that. And just so you are aware, whenever we start it, it's gonna spin the cutter, but know that it spins it in reverse. Okay, that's how it's designed. It'll spin in reverse, and it's gonna come down and touch that tool setter. So I'm gonna slow the rapid down to 40%, just personal preference, and then we hit enter to continue. Touches once, and it's gonna come down again slower and verify that touch off. All right, there it is. Now the machine's calculating the gauge length, or the tool length, our H1 value, that being 2.8973 inches. So now that we have our tool 1 touched off, it asks you, it stays in this program, and it asks you the tool number that you want to offset. You can escape out of that, or you continue setting up tools. This is where we're going to continue going down our list. And now I want tool 2, which is going to be our 1/2-inch 4-flute end mill. So I'm going to go ahead and type in 2, enter, and it's going to put tool number 1 away. It's going to grab tool number 2. It's not going to grab one because there's not one in the pocket. Turn our rapid back up. All right, so it thinks it has tool number 2 in there, so I'm going to go ahead and grab our tool 2 over here on the bench. And this is the 4-flute end mill that we're going to be using. This is a 1/2-inch diameter Walter cutter. And we go through the same process. So I'm not concerned about the exact diameter of our cutters at this time. So we're just going to use length only. So 0 for length, hit enter. Tool diameter 0.5. And now it's going to ask me to hand wheel it down in Z so that we can touch it off. And then if I want to use this guy, I can just turn this one off, and we're in Z. On this machine, it actually hand wheels a lot faster using this control versus the pendant control. You get it down close, within 200 or 300 thousandths, and you're ready to go. Now we'll touch it off. The machine will not spin it because of the 1/2-inch diameter. Anything over 1/2 inch, it will spin it, and you can run it off center so that we can do a proper touch off. All right, so now that one's touched off. Now we're ready for tool number 3. So we'll go ahead and input 3, enter. It's going to put tool number 2 away. Now it will grab tool 3, which is a drill. but I don't want to use this tool anymore, so I'm just going to take it out. All right. And then I'm going to verify what tool that we want. I got tool number 3 as being a 1/2 inch diameter 3-flute helical chamfer mill. This is one of my new cutters. I'm excited to see some updated chamfering that we're going to get with this cutter here. It's a beautiful tool from Helical. It's a proper chamfering tool right here with 3 flutes and should provide good finishing. We have minimal work to do with this guy on this job, but I'm looking forward to having this for many jobs ahead of it when we're doing just some chamfer work here. We want the length only. Tool diameter is 0.5. And now we can hand wheel it down. We're in Z. Hand wheel it down. All right, tool 3 touched off, we can continue on. Now, I don't want to bore you guys with all 10 tool installs here, but I thought I would just go ahead and show a few of these because we do get comments on our CNC videos that there's some people that would like to see a little bit more detailed explanation of our CNC work. And as I've said before, I still feel very, very new at all this stuff. I don't feel like I'm educated enough to give you a lot of really good information on what it is that I'm learning how to do. So I'm just trying to show you what it is that I do know and what I understand. I feel like I've gotten pretty good at the proper sequence of getting tools installed in the machine, and I've learned from errors on not touching the tools off that has caused crashes or tool breakages there. So whenever I'm ready to set the tools up, I try to just get them all lined up like I showed you over here on the toolbox, and then go through one by one and touch them off, because if I would have touched these tools off yesterday, I most likely would have questioned myself on whether I did touch the tools off, and then I would have gone through and touched them off again as assurance that I did touch them off, just because I have made those errors before. So you're constantly learning, you're constantly trying to improving, and I'm just trying to share what it is that I've learned with those that out there that might be interested. All right, so it's asking for the next tool number. We want 4. It's going to put that one away. There is an end mill in there, so we're going to pull that guy out, put it in the cabinet. This is a really cool Helical 5-flute chip splitter for steel right here. So we'll put it down here in the cabinet, store it. And our next tool in line is going to be our 3/8 diameter 4-flute end mill. And I'm verifying that with my notepad here. 3/8 4-flute. Length, tool diameter 0.375, and we're ready to touch it off. Our next tool to install is going to be this guy here. This is a 1/16 diameter 4-flute end mill. I did not have one of these cutters in my drawer, so I ordered this guy from McMaster-Carr. It's the SGS brand, tin coated. Hopefully that's going to be a good cutter. And the reason I needed a 1/16 end mill to help get this job done is on this part of the broken part, there's a channel right here. It's basically another step in there, but this is 80 thousandths wide. So 1/16 cutter, and we'll run right down the center of that to cut that out, and then we'll do a contour pass down each side to clean it up to the proper 80 thousandths width. All right, next tool in line, this is going to be a 4-flute ball mill. We're going to be using this one to do the 3D surfacing on it. On these 4 lands on the top, they have a slight angle on there, and we'll use our ball mill to be able to get that part of it done there. This is going to be a 1/4 inch 90 degree. This is a spotting drill right here, and what we're going to do is use that to spot drill and cut the chamfer for our 3 holes that we have to drill and tap there. That drill is going to be very, very close to these shoulders here. But according to our model in Fusion, it's got clearance, but it's going to look like it's going to be cutting it. So if I have it modeled correctly, that drill should clear the side of that. Our next cutter is going to be, this is a Cleveland 3.3 millimeter jobber drill. This is going to be our tap size for our tap, which is the next guy. We're going in with an M4 by 0.7 tap. So we have this installed in our Technics MicroFloat. This gives the tool some axial float in there to allow for any kind of misalignment in the threads as the machine is making its movements. And then our last tool, number 10, is going to be a 1/8 diameter 4-flute ball mill. And we're using this guy to do all of the deburring on all of the edges on the outside there. So 1/16 diameter. Oh, look at that, tool diameter, 1/16 already in there, 0.0625. Coincidence, that's what last tool we had in there on the tool diameter. Okay, I got you at the desk here, and let's check out our model that we created and some of our cam work. So backward engineering is can be a little tricky sometimes. Not that it's so hard to create something, it's the time involved in trying to get the proper measurements on a piece that you need to measure and model up. But I was able to get it done, and I was going to show you. This is kind of the process in which we start right here. So I just create a couple of hand sketches like this here and do some measuring, and I use my calipers for this. So I got my good Starrett dowel calipers that we use to measure our sample, and I jot all these dimensions down here so that whenever we come over here to the computer, you can kind of get through this a little bit quicker instead of having to sit here and measure everything as you need to draw something. So just start with some kind of hand sketch. That was another one here that just shows the overall finished dimensions of our workpiece. The width of these lands right here being 180 thousandths and our corner radius being 7/32. I measured that with a radius gauge, and that's as close as I could get it. So this is what we start with right here, and then this is our final design in our modeling in Fusion. And I'll rotate this around a little bit and show you what it looks like. Now, one thing I was going to point out that I think I forgot to mention earlier is the bottom of our the piece that we're copying has got, you know, some channels that were cast into that. They said not to put those in there. They didn't need to be in there, so we eliminated something that didn't need to be machined. So it's just going to be a flat bottom there. All right. And a couple of things I wanted to point out with the model is if we go to the front view here, you can kind of see how this is a bit of like a stair step, you know. So you have your lower level here, which is where the holes are drilled and tapped, and then you have a level here, and then this being the top, the tallest level. But these four ribs are in different places on that. It's not symmetrical from the end or from the center. So you can see, like right here, this is the area that I was talking about. This is an 80 thousandths wide gap here. Why we're, you know, using a 1/16 end mill for that. And that's the same level as this little corner right here as well. That's the same height anyway, should I say. And we've got our four bevels, our four faces there that are cut on an angle. That's the one where we'll use our 1/4" ball mill and just do like a, you know, a 3D surfacing type tool path on there to kind of cut those angles. So that's really it. What we'll do is we'll jump over to the manufacturer, and op 1 is going to be, let's see if we can bottom home. All right. I like creating a named view that makes sense to the orientation at which we're going to be machining it. So we'll just go ahead and run through our simulation. It's going to be tools 1, 2, and 3, which would be our face mill and our 4-flute 1/2-inch diameter end mill. All right, and we'll go ahead and play this. I'll speed this up a little bit. So we're going to take a face cut, 20 thousandths to clean that face up. And then we're going to come in with our 1/2-inch 4-flute end mill. We're going to use a 2D adaptive tool path to cut this out. It's going to leave, I believe I've got it set to 10 thousandths on the wall. And then it will come and do the 2D contour tool path to clean up that outside. All right, so there it is cleaned up. Now we're going to come in with our chamfer mill and just break that edge off. I've got it set to a 5 thousandths chamfer break. And then that'll be all for op 1 there. We can exit this. Now we're going to go to the top, which will be our op 2. And we'll go ahead and simulate this one next. And we're going to come back in with that 2-inch face mill. And I don't want to be too aggressive with this. And we're cutting 303 stainless, so it's pretty easily machinable. But we're clamping this in soft jaws. I don't want to overdo it. So we've got this set to a 50 thousandths per pass cut. And I believe that was either 4 or 5 passes across that. And you can see what that's going to do. That's going to remove the hat. And it'll also finish off, I think we're going to make one more path across there. Now this is going to be a rapid movement, so it won't be moving at that speed. And you can see the top of 2 of those ribs that's going to touch there. Now we're going to come back in. This time we're using a 3/8 diameter 4-flute end mill. And this is a 2D adaptive tool path that we're using. And it's going to come in here and it's going to rough out all of the material that needs to be taken out of here. We're going to speed this up just a little bit. And this is going to be cutting between 2 of the ribs here. And that 2D adaptive, in case folks are not really sure what the benefit of the adaptive is that it's constant engagement. So whatever engagement you have the tool set at, chip load on there, it's going to maintain that same load every time it comes in and makes a cut. So you don't have to concern about overloading the tool in a certain area because it's going to maintain that same cut. All right, so we'll speed this back up a little bit and you can see that it's going to come through here and slot this section and finish roughing everything out. Notice a couple of stair steps over here. That's the material that we're leaving, and we'll have the 1/4-inch ball mill clean these sections up right here. All right, so roughing out that last step. Roughing out the last rib. It may come over here and do a little bit more. Let's see, I can't remember now. All right, now we're on our flat tool path. That's going to finish the faces between the ribs. All of these faces right here, it's going to come in and clean those up. All right, that's looking good. And then it's going to another facing tool path that will clean up the top of these 2 ribs. Now we're on to a 2D contour. There is our 1/16 end mill right here. It's going to 2 passes down the center of it, 2 different step downs, and then it's going to cut the side, clean the side up. I believe I've got it set at 2 passes there. It's a very small cutter, so I wanted to try to be careful and not overload it there. One more cleanup pass right there, and then that one's done. Now we're doing a flow. I believe that was 3D flow, the tool path, and using a 1/4-inch diameter ball mill. And you can see I've got it set to a 5 thousandths step over, and it's just going to run back and forth across that face, cleaning this up flat. And I was concerned that it was going to hit this corner right here, but according to Fusion, it's going to just miss it. You can see. I think it's going to just miss that there. Let me go back to, no, I want the other home position, not the bottom home, I'm sorry. All right, so we'll speed this up here and get through our flow tool path to clean up those angular faces. And then once it's finished with that, we're going to grab our 1/4" spot drill, and it's going to, I've had a lot of people recommend this. We're going to give this a try this time. So it's going to come down and it's going to spot drill it, and I've got it set to a depth so that once it comes down and cuts, it should cut it out to the diameter that we need that will finish the chamfer. So instead of having to come back with a separate tool to cut a chamfer should be there once we run our drill and tap through there and get that hole cut. All right, so now we're going to come in with our drill, 3.3 millimeter jobber drill to drill out the 3 holes. And then next up is our M4 tap. Pretty simple. Rigid tap M4. And then our last tool path is a 1/8 diameter ball mill. And this is what we're going to be using to deburr all the edges. And this is the deburr tool path on Fusion. This is an add-on, and I am so glad that I have this on my Fusion, because this is one of the most beneficial tool paths, I think, to be able to use a ball mill or a chamfer mill, whatever makes sense, and completely deburr every single edge on this part. Does such a nice job. And then there it is. There's the end of the program. So we're going to go back out to the machine. I need to get our 2 work offsets set. We're going to do that, and then we're hopefully going to have a successful run and make a part here. Our right side vise is going to be op 1. Left side vise is going to be op 2. So we are using our Talon grips to hold it for op 1. That'll do a really good job of biting into this flat bar material. I do have a work stop set bolted in there as well. So I'm going to get this one in there and get it tightened up. That's good and tight, and we'll move over here and get a piece set up here too. Actually, you know what? I'm going to use a setup block for op 2, so we're going to do that one separate. We'll go ahead and get our probe and get this one set first. Okay, I've got the Renishaw all set up, and we're getting ready to probe this. I wanted to point this out too. Here's my tool list that I wrote earlier. I'm trying to get a better habit of this whenever I come out here and I do our work offsets. I've got op 1 and op 2 origin written down here, because sometimes they're a little bit different. So on op 1, our XY is in the center of our stock, and the Z is going to be off the top of our stock. Now, whenever we go to do our op 2, I was going to show you this on the computer and I totally forgot. We're going to be using the top left corner as our origin. So we need to probe on the corner here. And our Z is going to be off the bottom surface. So we'll do that one, but what I wanted to point out was that writing this stuff down so I don't have to keep going back and forth and saying, all right, well, where was the origin at? Because I don't remember. I write it down so I don't have to remember. I can just look at my notes there. We're going to be using a web operation, x-axis, our length is 3 3/4, work offset G54, X position is 0, and we're approximately 300 thousandths above the part. So let's go ahead and hit run and cycle start. It'll verify where the top of the workpiece is, and it'll touch off both sides of that, as long as you got your distance set in there correctly. All right, yep, there's our 0 for G54 and X. Let me reset this for Y now. All right, web operation, Y-axis, width is 1 1/4, G54 offset, Y position is 0. And we're above the part. We're going to hit run, cycle start. It'll verify the top of the workpiece again. Then we'll move off in the Y direction to find the center. All right, Y0. Okay, let me reset for Z. Okay, single surface, Z-axis, G54, distance to part is -3, and we want our Z position 0. We are ready to run it. It'll just touch the top of the part, and that's going to be our origin. Let's see how close to the distance we were. We're at a Z value of positive 0.258. All right, so that guy is ready to go. We'll go ahead and move down to the left side vise and get our Op 2 set up next. All right, for our left side vise here, we're going to be using my Starrett 706 setup block here. This is a precision 1-2-3 block. And the reason why we're going to use that is because whenever we set our workpiece in here, we want to locate off of this corner, X and Y on this corner. And I don't want to use a piece of stock because it's going to be milled, it'll have a hat on it. So just use a block, push it up to your work stop there. And then when we probe it, we'll use a corner cycle. And then the other thing is our Z. So I really want my Z, the origin is going to be down here in this step that we milled, the bottom of the workpiece. So when you use a precision block like this, use your probe, and since this is a precision 1-inch thick block, whenever you probe this, you can just adjust your Z so that it will go down negative exactly 1 inch, and that'll put us on the bottom of the stock there. This is our probe cycle for finding Op 2 Z. So we're using single surface Z axis, and our work offset is G55, making sure we don't mess that up. -3 to distance apart, and then there's our value that we want to make sure is in there, and that'll take it down to that surface of the step in the jaws. Our Z position, -1 inch, and we're ready to run it. Okay, there we are. All right, I'm gonna reset probe for our corner. So I'll just show you, to start this, we're gonna have to go ahead and jog it over, or hand wheel it, should I say, over to that corner. We're just gonna eyeball the corner of it. Somewhere about there. Now I'll go ahead and get it set up. Here's our probing op for the outside corner. So we've got the outside corner selected here, and then we're going to be probing off of the top left corner, G55 work offset, and then our X and Y positions are going to be 0 on that corner, and you just want to make sure it's -0.3 over the corner. And then you can add additional depth there to it by putting it in this field here, and we have to do that every now and then, but otherwise we're ready to probe it. All right, start and cycle start. Here we go. It'll move over a little and make sure that it verifies the top of the workpiece right here, and then it's going to go through its cycle program. It takes a little bit longer than the other two, or the other ones that we typically use. I believe it'll find X first. Then it'll find Y. Still calculating. It's going to come up in Z. And now it's finished. It's calculated our X and Z position. All right, I just jogged it over there to the very corner of our G55 work offset, and I'm just kind of looking at my current position to be sure that it looks like it's right, and it does. We can visually see the probe on the corner. This is 0, 0, and our Z is a positive 1.241, and you can see that our probe is about 1/4 inch above this and go down another inch. That should be our Z0. So this should be right. I'm going to go ahead and get our program loaded up, do some verification, and then we'll be ready to send it on Op 1. On our controller here, you can do a preview on this, which is what I was doing. So if we go back, this is your text editor right here. This is the program that we're actually cutting. So when you want to make modifications to your program, this is where you come in here and do that. But down here, F11 preview, you click that. I've already got our stock size adjusted, and this is showing the tool path. So a face mill, and then a 4 flute 1/2 inch end mill for the 2D adaptive, and then the 2D contour, and then we've got a chamfer mill that's going to break the edge. So this verifies that it looks like everything's correct. So from here, we're just ready to send it and make some chips. I cheated you guys. I went ahead and cut the first piece, and I did that because it's much easier for me to concentrate on what I need to concentrate on, making sure the tool is right and the program's right, versus having a camera, making sure everything is correct, and talking to you and explaining things, all that good stuff there. So we have a successful Op 1. And I ran this dry, and that's how I plan on running this. And the reason why I'm running it dry is because I want to give you guys a good video. I want to be able to you know, get in there with the camera, see the shot, you know, see the cutters doing its cutting action, and make a good video for you. So everything worked out really good here. I used my calipers and just did a caliper measurement. It looks like within, you know, 1/1000ths of being on our dimensions that we want on our length and width. So I'll put another piece of stock in there and reset, and I'll show you what this Op 1 looks like being cut. I'm not really happy with the finish on the face mill on the top there. I dropped it down. I made another pass. I dropped our coordinate down 1/2 thousandths and cut it again, and then another 1/2 thousandths, cut it again. It's still not giving me the finish on there that I really want. So I think I'm going to make some changes to our program. I'm going to do some more testing off camera and see if I can get at least a better looking and feeling finish on the top of that. The side of it for our end mill is doing good. So what I'm considering doing is just eliminating that 2-inch face mill and probably just using our 1/2-inch diameter end mill. Make a couple or probably 3 sweeps across the top of it for our facing program, and try that out. So I'm going to do some more adjusting off camera, see if I can improve this, and then I'll bring you guys back whenever I have some better results. I made some edits and I think I'm getting better results now. I was digging through the box and I remembered that I have one of these Imco that's the M936 power feed. This is a 6 flute end mill, and it's rated for cutting stainless. So we took the face mill out. This is the face mill, I'm sorry, this is the end mill here. And I just made some adjustment to my program, and then I dropped my coordinate down -10,000 so that it would cut the top again. And now we have a nice looking finish on there. It's nice and smooth, and we even have a better finish on the side. So I think that end mill there is going to do a better job than my 4 flute was doing. So we're going to give that a shot right there and see. I mean, it's going to look like that. I've got one more sample piece over here to cut, but I think since I got good results on that one, I'm going to go ahead and stick this one back in there and see if it will line up. It may not line up perfectly because we're using the Talon grip, but I'll give it a shot and see if we can recut that one there as well. Here's a better look at the finish after we went around it with our 6 flute end mill. So now I'm happy with the results. I think we're getting a better finish now using an end mill, and I'm happy that it cleaned up the side there as well. It's got a good feel to it, which is what we want for, you know, satisfaction when you have the part in your hand and you're looking at it. Looks like I can see a faint line down the finish of that. That must be on the cutter itself. I have used that cutter quite a bit over the last couple of years, but it's still getting the job done. I think that's going to look good. I believe once that's flipped over, I don't know, you may see that line, I'm not sure. Here's what the profile looked like. I think it's going to be fine. You can't even feel it. So I think we're just going to run it like it is there. This is pretty good. So we got one more piece that we can cut for op 1. We'll go ahead and stick that in there now and cut this one more time, you know, our full depth program there from our stock. Looks like it worked out great. Got a good feel to it, just like the other one. That end mill does a really good job. That's the first time I've used it on stainless steel, and it worked just like they said it would.